Okay, we continue with the multiplication rule of the independent probability. Now we will be looking at the combination approach, how we can use the combination and the factorial symbol to also explain some of the distribution. The term factorial, we use this sign to indicate factorial. It can easily be seen on our calculator. Now this one is also another form of operation sign. You know, the operation signs are not the only addition, subtraction, multiplication, and division, but we call the union, the intersections, the subset, and factorial. We got many. So now we're going to look at how this one also can be used in the probability distribution. When you have got a distribution like n factorial, what does this one mean? It means that you have to reduce this one to the least possible, that it cannot be reduced again. So in this case, n factorial is going to give me n minus 0. The next one is n minus 1. Then I continue up to n minus r factorial. Now the bracket here indicates that we will multiply the fact. For instance, by being given a figure like, let's say, 4 factorial. How does this 4 factorial mean? From the formula I've given here. So it means that 4 factorial is going to give me 4 minus 0. Then I've got 4 minus 1, 4 minus 2, 4 minus 3. I won't go to 4 minus 4 because it could have also been gone, but 0 factorial is the same as 1. So this one is going to give me 4 factorial will now be equals to 4. If I subtract 0 from 4, I'll be left with 4 times, here we use the dot sign, times 3 times 2 times 1. So this one gives me 24. 4, 3, 12 times 2 is 24 times 1. So 4 factorial gives me 24. Now we use since during probability we select, so we'll be using the demonstration like we have the simple combination. Okay. Now it is also another form of selection. And over here, the order of arrangement is not very important. So when we have a relation that the formula is being given as n choose r, you've gotten some items you are selecting. In probability, we always choose an outcome out of the general sample spaces. So n choose r is given here as n factorial divided by n minus r factorial, r factorial. The axiom states that n will always be greater or equals to r, but r can never be greater than n. N will always be greater than r. So if I've got a distribution and I'm being asked to work something on probably let's say 3 choose 2. I've got 3 items, I'm choosing 2. How am I going to choose 2 out of 3 items? So using this distribution, I'm going to get as it is on the formula. So you can look at it from here. So it means I'm going to have what? The top, which is 3 factorial, now divided by 3 here, minus 2. This is 3 minus 2 factorial, then 2 factorial. So in my expansion, now the 3 factorial goes like when we have n factorial. So you have to reduce it to the point that it cannot be reduced again. So if, again, when you are reducing, look at the extent of the denominator. So 3 factorial, the first aspect is if I will subtract 0 from 3, so I'm going to get 3. The next one will be 2. the next one will be 1. That is, from the initial phase, let us come here. Now, if like we have 4 minus 0, then minus 1 in that order. So it means that for the first instance, I subtracted 0 from 3. Then the next one, I subtracted 1 from 3, 2 from 3. So I cannot go further. I just have to leave it like this. Then with my denominator, if I subtract 2 from 3, I'll be left with 1 factorial times, there's already 2 factorial here. So 2 factorial is 2. So 1 factorial cancels 1 factorial. Then 2 factorial is 2, 1, 2. So that one also will cancel this. So I'll be left with what? 3. So if I've got 3 items, if I'm to select 2 out of 3, the number of ways I can select 2 out of 3 is 3 ways. So the number of ways I can select 2 out of 3 is 3 ways. Now we are going to employ this in our probability distribution, whereby we are employing the independence law. Over here, the order of arrangement to some extent are also very important, so we will consider. Okay, let's look at this example. See, a bag contains 5 red, 6 white, and 4 green balls. If one ball is picked at random, what is the probability that it is not green? II. If 2 balls are picked at random without replacement, what is the probability that one is red and the other is green? So let's see how we can solidify this question. To be able to solve this question, first we must find the total sample spaces. So we have to list the outcomes of all the balls. So we have how many red do we have? So number of red here, number of red balls here equals to 5. Okay, then we got white balls. White balls equals to 6. Then green balls equals to 4. So the total here is given as 10, 15. So we got 15. So total balls equals to 1, 5. Good. Now we take the question. Let us look at question 1. What is question 1 saying? If one ball is picked at random, what is the probability that it is not green? It means that if it is not green, then it is either white or red. It is either white or red. In this case, we have got a total sum of balls in the box to be equals to 15. So probability that if one ball is picked, it is not green, we just write P, that is I. We got I here. So P of not green. Okay. So if it is not green, means that it is the one that is selected is either red or white. So if it is not green, it's going to be equals to, it's either red or white divided by the total outcome. Okay, divided by total outcome. And I explained to you earlier that the term or indicates multiplication, addition. So if it is either red or white, it means that how many red do we have and how many white do we have? So this one is going to be the total number of red plus white, which is going to give me 11. So this one, I'm going to get total number of balls. That one is selected. So 11 choose 1 divided by the total number, which is 15, choose 1. But we are saying that the total number of balls are supposed to be 15. And 1 is chosen. What is the probability that it is not green? If it is not green, then the remaining 11, which is the 5 red and the 6 white, 1 is chosen. So that one is what we are going to work. So with this, you just point using your calculator. Look at where you've got 11. Just point 11, 1, 1, which will give you 11. Then go to second function on the calculator where they've written shift. You punch on the shift. Then you punch on division. You will see C on the calculator. Then from there you indicate it with 1. So, okay. First thing, so we are going to use the calculator. First, you are going through this session. Now what you enter is that you just point 1, 1 on the calculator. Then you go to shift where we got shift or second function. Then you come to division. You will get C being displayed on the calculator. This one is not clear. So when you see the C, then you enter 1. So let me take it again. I want to say 11 choose 1. So it's 1, 1.